In this video, we are going to discuss electrostatic potential at a point due to an electric dipole. Let us consider a dipole. Dipole is the equal magnitude and opposite charges are separated by a particular distance. Here the distance is 2a. O is the midpoint of the dipole. Then OA is equal to OB is equal to A. The dipole moment vector direction is always from negative to positive. If a test charge is placed at P point from the midpoint of the dipole with the distance r, then the distance between the positive charge and P point is r1. Then we can find out potential at P point due to the positive charge is 1 by 4 pi epsilon naught into Q by r1. The distance between negative charge and P point is r2. So that we calculate potential at P point due to negative charges minus 1 by 4 pi epsilon naught into Q by R2. Next, we have to calculate total potential at P point due to this dipole. So we have to add these two values. Here Q by 4 pi epsilon naught values are common values. So we take total potential is equal to Q by 4 pi epsilon naught into 1 by R1 minus 1 by R2. If BOP angle is theta, then AOP angle is 180 minus theta according to linear pair of angle. In this potential equation, R1 and R2 values are unknown values. A and R values are known values. Using these two values, we have to find out R1 and R2 values using parallelogram vector addition or cosine law. More or less, cosine law and parallelogram vector addition formulas are same. Cosine law says c square equal to a square plus b square minus 2ab cos theta, where c is the unknown side of the triangle, a and b are known sides of the triangle, theta is the angle between known sides of the triangle. So here in this BOP triangle, we can use cosine law to find out R1 value. So that R1 square is equal to R square plus A square minus 2AR cos theta. Next, we have to take R square as a common term. For math students, it is very easy. For bio students, just follow my suggestion. Multiplying and dividing this and this term by R square, we get R square, A square by R square. Here, 2AR into R square by R square. Dividing this, that is cancelling this R on the numerator and denominator or we get 1 by r, the 1 by r into r square. So taking r square as a common term, we get r square into 1 plus a square by r square minus 1 by r into 2a cos theta. So here when r is greater than a value, a square by r square value becomes negligible amount, so that we ignore this value. So we get r1 square is equal to r square into 1 minus 1 by r 2a cos theta. But we have to find out 1 by r1 value. So that first we find out r1 value. Taking square root for r square we get r, and for this value we get 1 minus 1 by r 2a cos theta whole power 1 by 2. So next we have to reciprocal this value to get 1 by r1. So for this it becomes 1 by r. For this this exponent term becomes a negative value. Next we have to expand this 1 minus 1 by r to a cos theta whole to the power 1 minus 1 by 2 according to binomial theorem, that is a minus b whole to the power of minus 1 by 2. Here we are going to consider only the first two values because other values are very negligible amount, so we can ignore that other values. So that the first two values are 1 plus a by r cos theta. So 1 by r1 value is 1 by r into 1 plus a by r cos theta. Next, we have to find out 1 by R2 value. For this, we can change only theta value. Here, theta is 180 minus theta. So, cos of 180 minus theta minus cos theta. So, that 1 by R2 becomes 1 by R into 1 minus A by R cos theta. Now we have 1 by R1 value and 1 by R2 value. Substituting these two values in this equation, we get this one. Taking 1 by R as a common term and cancelling this 1 and minus 1, we get V is equal to Q by 4 pi epsilon naught into 1 by R into 2A by R cos theta. Here this R into R becomes R square. Bring this Q into the bracket. We get 2AQ by R square cos theta. We know that 2AQ is the dipole moment value, so that this equation becomes 1 by 4 pi epsilon naught into P by R square into cos theta. That is 1 by 4 pi epsilon naught into P cos theta by R square. Here we can consider this P cos theta as P vector dot R cap, because dot products of P vector and R vector is equal to PR cos theta. If R value is the unit value, we get P cos theta is equal to P vector dot R cap, where R cap is the unit vector. Substituting this P cos theta value in this equation, we get V is equal to 1 by 4 pi epsilon naught into P vector dot R cap divided by R square. Now we see some special cases, that is how theta is affecting this electrostatic potential. If theta is equal to 0, the P points lies on the axial line of the dipole on the side of the positive charge. Here theta is equal to 0 degrees, so that cos 0 is equal to 1. Potential becomes 1 by 4 pi epsilon naught into P by R square. If theta is equal to 180 degree, the P point lies on the axial line of the dipole on the side of the negative charge. Here theta is equal to 180 degree, cos 180 is equal to minus 1. So that potential becomes V is equal to minus 1 by 4 pi epsilon naught into P by R square. If theta is equal to 90 degree, the point P lies on the equatorial plane of the dipole. Cos 90 is equal to 0, so that potential becomes 0.